practice quiz for derivatives. We're mixing and matching all of our shortcut rules to find derivatives. Power rule, product rule, quotient rule, chain rule, the rules to help us find the derivatives of exponential functions, trig functions. Make sure you know all those. And they get tricky when you're mixing and matching them. So let's do a few of these. Of course, one of the first rules we learned is when we have a function that's made up of a whole bunch of terms added together or subtracted, you can just take the derivative of each piece. So let's do that. Of course, the derivative of y of x is y prime of x. You have to do the derivative of both sides. Derivative of x to the fourth, just your power rule. Derivative of 6 times the sine of x, that coefficient hangs out and is just multiplied times the derivative of sine of x, which is cosine of x, plus, here we have another coefficient, that 8 hangs out and is multiplied by the derivative of 7 to the x, which is, of course, the natural log of the base times the exponential piece as it was. All right? There you go. Let's try number 2, shall we? When we analyze this, I hope when you do your analysis you see there's a product here. You have e to the x times cosine of x. You're going to have to use our product rule. The derivative of the first times the second as it is, plus the first as it is, times the derivative of the second. Right? Where e to the x we'll consider our a, cosine of x we'll consider our b. All right? Derivative of g of x is g prime of x. Here I go. E to the x, that's an exponential piece, so natural log of the base times the exponential as it is. That's just an x, so you don't have to worry about the chain rule. Okay, that's my a prime times b as it is, cosine of x, plus a as it is, e to the x, times the derivative of cosine of x, which is negative sine of x. All right, to simplify this, not too involved, natural log of e, of course, equals 1. So that's just e to the x times the cosine of x. Here, whenever you have a negative in the middle of a term or any constant in the middle of a term, you always want to bring that to the front. Otherwise, it's a little awkward. So I'm going to say that's minus e to the x sine of x. This, my friends, would be considered fully simplified. But if you want to, you could also, which we sometimes do, factor out the common term. Often after we take derivatives, we factor out the common term just so we can look at it a little more easily. But either one of these would be considered fully simplified. Okay, are we having fun? I know I'm having fun. All right. Ooh, 4. Right when I look at that, I think quotient rule, and I'm going to have a chain rule, because that's not just the square root of x, it's the square root of a more complicated function. Or, hey, I could just rewrite this and just do the chain rule. So look what I'm going to do. That would be 2x minus 1 to the negative 1/2. Does everybody see how I'm doing that? 2x minus 1 to the negative 1/2. Let me just erase this so it's not in our way when we're looking at this. Okay? How do we feel? Again, you could do the quotient rule. You'll get exactly the same answer. So I've got an inside function and an outside function. The outside function is just my power. Something raised to the 1/2. How do you take the derivative of something raised to the negative 1/2, I meant? The power rule. So I'm going to do a big power rule. Derivative of f of x is f prime of x. Big power rule. Negative 1/2 times that all as it is, raised to the negative 1/2 minus 1, which is negative 3/2. But it's not just a simple x raised to a power, it's a function raised to a power. So this is the derivative of the outside. Now I have to multiply it times the derivative of the inside, which is 2. Everybody see that? So this is the derivative of the outside, and this is the derivative of the inside. And of course, the inside is the function that was put in as your input. Okay? Now, let's go ahead and simplify that. Whenever you have numbers, constants, you always want to multiply them together, bring them out front. -1/2 times 2, -1. So I could just write that answer as negative the quantity 2x minus 1 to the -3/2. Totally fine to leave it like that. Or, if you wanted to, you could write that as -1 over 2x minus 1 to the 3/2. Either one of those would be considered fully simplified. All right, let's do a few more. Let's look and see what's on the next page here. Oh, I'm not going to do this, but you could do the quotient rule, but you don't have to. You could rewrite this. Ooh, see how I just rewrote that? That's just a constant. So you could just do your chain rule, like a bit of, what the heck, I'm doing it. 4 times 1/2. There's no x with that 1/2. So you can just treat it as a constant, right? 4 times 1/2 is 2, times that whole shebang. I just did the derivative of the outside times the derivative of the inside. Da, 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 da. And you could consider that fully simplified. It's just one term. That's good. All right, that was fun. Ooh, yeah. Whenever you see a trig function like this, just go ahead and rewrite it, because I think it's very confusing, that notation. What that notation means is really this. It's that entire function raised to the 4th. Now, this is going to be interesting because I have an outside function. My outside function is a power of something raised to the 4th. So I'm going to start by doing a power rule. But there's an inside here, right? So chain rule is going to kick in times the derivative of the inside. But that inside has an inside. So it's going to be a chain with a couple of links. Let's see what that's going to look like. Derivative of f of x is f prime of x. So here I go. Big power rule. 4 times that whole shebang to the 3rd. And when I say the big shebang, that never, it's just the inside as is. Okay? There's the derivative of the outside. Times the derivative of my inside. So the derivative of the tangent of something is secant squared of that something. Times the derivative of the inside of my inside. The derivative of 3x minus 1 is 3. Now in terms of simplifying this, really all I'm going to do is multiply that 3 times that 4, put that out front so it really looks like a nice coefficient. You can leave this like this or use the notation that you often see. That would be considered fully simplified. All right? Okay, ooh, there's a humdinger. Let's do one more, okay? All righty, quotient rule, clearly. Wow, we didn't have a product rule on this. Okay, quotient rule, here we go. Maybe we did have a product rule. Oh, we did, good. Let's do the quotient rule for this. Remember, you have a numerator, you have a denominator. It's the derivative of the top times the bottom as it is minus the top as it is times the derivative of the bottom over the bottom squared. Here we go. The derivative of y of x is y prime of x. Okay. The derivative of my numerator. Okay, that's an exponential function, so it's going to be the natural log of the base times that exponential function as is. Hey, that's not 2 to the x, it's 2 to the 3x. I put something inside that exponential function. So the chain rule kicks in times 3, right? 3 is the derivative of the inside. In other words, the derivative of the exponent. There's my a prime times b, the bottom as it is, minus the top as it is, times the derivative of the bottom. Ooh, I've got an inside and an outside. Chain rule. 3 times 6 minus 2x squared times the derivative of the inside of that, which is going to be a negative 2, all over my denominator squared. Okay. Very interesting. Okay. So now, how to simplify this? Well, whenever you do the quotient rule, lots of times you can distribute things out in the numerator and combine like terms, but that's not going to happen here because I've got exponential functions and polynomials. The other way you can sometimes simplify is down to up. And I'm thinking I'm going to be able to simplify something down to up. Okay? I've got 2 terms in the numerator, and they both look like they have a 6 minus 2x. Do you see? 6 minus 2x. There are 2 of them here, 3 of them here, and I've got 6 of them here. I'm just going to do this quickly. Remember, when you raise an exponent to an exponent, you multiply those exponents. So could I not divide out all 2 of these and 2 of these and divide out 2 from the denominator? I think I could. Everybody see what I did? I just divided out a common factor of 6 minus 2x squared from this term, and from the denominator. And then my final answer would just be my leftovers. I have the natural log of 2 times 2 to the 3x. That constant there I'm going to bring out front and call it a coefficient just because I like doing that. I have 1 of those, 6 minus 2x, minus, I have a 2 to the 3x. 3 times negative 2, that's going to give me a negative 6 times a negative. So I'm going to put the positive 6 as my little coefficient there. All over 6 minus 2x to the 4th. This would be considered fully simplified. Now you might also want to, wow, that was crazy what just happened. You might also want to do some more factoring. Sometimes in situations like this, we factor a little more and say, hey, there's a 3 in both terms in the numerator. There's a 2 to the 3x in both terms. So I'm going to factor that out. That leaves me with a natural log of 2, times 6 minus 2x plus 2 in the numerator, and the denominator 6 minus 2x to the 4th. Okay? So you could also write it this way. Okay? All right, so there are some of these to help you with these. Make sure you do a lot of practice before the quiz. Thanks.